All right. Today we are talking about compound inequalities involving and compound inequalities involving or. Two new words for you today is conjunction and disjunction. Everybody say conjunction. Conjunction. Everybody say disjunction. Disjunction. Okay, so basically the way the chapter works is we're going to learn how to show conjunctions and disjunctions. We're going to learn how to show inequalities on the number line, and then towards the end of the chapter we go to the coordinate plane. Okay? So the first thing we're talking about is a conjunction. It's very important that you know that a conjunction is an intersection. This is an and statement. Okay? It's an intersection, it's an and statement. So it's an intersection, this is the symbol we use, and you need to make sure that that and is attached to it. Okay? Intersection and that the and. You might get something that looks like this. The word and implies that it is an intersection. So it says, write a compound inequality that describes all real numbers greater than -2 and less than 5. So we used to do like x is greater than -2. Don't write this part. And x is less than 5, right? And then I'd have this, and I have -2, here's 0, here's 5, and then we'd go like this, and we'd go to here, and we just connect that line, right? Well, when you see something like this, we can also do something called an in-between statement, okay? Do you need to write all those numbers down, by the way? No, just 0 and the numbers you're graphing. I don't want you to do it like this, where you show one line is going in one direction, the other is going in the other. So I want you to show it with one line. It goes from -2 is one boundary, +5 is the other boundary, and all numbers in between, we connect it. And how do we do that? We show it with this in-between statement. One way to look at that is we can do, I'm trying to get out of that. Okay, what's the lower boundary? -2. -2. X is in the middle. What's the upper boundary? 5. And we always write it going to the left. Do I write an equal sign underneath?
No.
Why?
Because it says real numbers greater than 2 and less than 5.
Right, doesn't say equal to. Okay, questions? Yes.
If it was equal to, would you fill in the circle?
Yes. Okay, so these and statements, these conjunctions, okay, a lot of times when you see something like this, you know it's called a conjunction. If you see the word and, it's a conjunction. It's also an intersection. It has to be part of both groups. Remember, an intersection, let's say I'm having a party, Julia, and I said, all people that are invited to the party have to have pink hair and be in my 3rd period class. So you would have to satisfy both of those sets to get an invitation to the party. Does that make sense? So who would be going to this party, by the way?
I don't know. I don't know.
With pink hair?
You said the
and 3rd period. Oh, yeah, you're right. Yeah. And pink hair in 2nd period. Only Gracie. It would be a pretty boring party. In order for that to qualify, if I'm having a party and I invite pink hair and 3rd period, nobody would be invited. Right? Because she's only satisfying the pink hair, not the 3rd period. But if I said the party was pink hair and 3rd period, she'd be the only one at the party. Still not a fun party, right? We need more than just one human being. Okay. What'd you say?
I said accurate.
What?
3rd period again.
Oh, okay, I meant 2nd. Okay, next one. Okay, so now we're going to turn these compound inequalities into in-between statements. Remember, we take the lower boundary, which is -3. We take the upper one and it goes on the right. We put x in the middle, and we always face our arrows to the less than. It would never be written like this. That's okay. It would never be written like this. Do you understand? With the bigger and the arrows going on the right, we always put it in order from least to greatest. All right, pause the recording and do number 2 and 3.
Yeah, I got 4 is less than x less than 10.
Perfect. And then the last one is, how do I write it? How about Fionn? Go.
-8 is less than x, which is less than -1.
Okay, did everybody put that one in order? Mm-hmm. Notice I gave it to you and with -8 second, but we always have to put the smaller one on the left. Okay? All right, so here's what a compound inequality might look like. There's 2 ways to do it. I suggest not writing down the left way and only writing down the right way, because the left way involves a lot more work. So this is really like 2 different inequalities. -4 is less than x plus 3, and x plus 3 is less than 7. And so then we would subtract 3, right? X is greater than -7. And on the next one, I'm going to subtract 3, and x is less than 4. And we then write it into an in-between statement. -7, what would that look like?
-7 is less than x, which is less than 4.
Good. And then we put it on the number line. Okay? But if you have something like this, really, write the right side. Those should be your notes. We are going to just subtract 3 from all 3 parts of the inequality. Yes, you're writing this one. And then we have -7 is less than x, which is less than 4. Which way is easier?
The second way.
Right. Conjunctions, most of the time, 90% of the time, except for the exceptions, there's exceptions and there's most of the time. It will look like one line on the number line with 2 dots that connect it. Okay, there will be some exceptions we'll look at the end. Any questions here? All right, we're moving on. So what do you think we would do first here? Imagine that 7 is not there. What would be the first step? How about Jamie?
Subtract 4 from all sides.
All 3 parts of the inequality. And then we get, what would be the next step? Go.
-9 is less than 3x, which is less than or equal to 3.
Good. And now, what am I going to do? Let's go. Sophie? Chloe, sorry.
You divide by 3.
Divide all terms by 3. And we end up with?
-3 is less than x, which is less than or equal to 1.
Good. Okay, and then we go and graph it. From the low one. How is this jumping in, Julia? From not being here. Their air conditioner or heater. Do you want the heater or air conditioner on? Okay, so we're going from the lowest one is -3 all the way to 1. Questions? All right, let's try the next one. Why don't you pause the recording and I want you to try the next one on your own. Okay, what do I need to do? I don't want to know what you got. I want to know how do you prove yourself.
Subtract 6 from all 3 sides.
Right, so we are subtracting 6 from all 3 sides, and then you're left with?
And then you're left with -10 is less than or equal to -x is less than 2.
Good. Okay,
And then you divide by -1 on all 3 sides.
good. And now what happens when you divide by -1?
It becomes 10 is greater than or equal to x.
Every time you have to flip the inequality sign.
It's greater
so-
than -2.
10 is greater than
Is greater
or
than
equal to?
x is greater than -2.
Okay, and then we have to put it in order. What goes on the left?
Negative 2 is less than x is less than or equal to 10.
Good. And then we're going to write a number line. And
10 is filled in and 2 is not filled
open circle at 2, solid circle at 10, and we're going to draw the line to connect them. Questions? Who remembered to flip? Okay. We've talked about conjunctions. Those were and statements. Now we have disjunctions. Like disconnected, disjunctions are or statements. These are unions. Conjunctions are intersections. They're intersections. They're and statements. They're one line. Disjunction is a union. We use the U to represent. Okay, and you will see the word or. That's what will be important. So as soon as I see this, or, right here, I know that I have to set this up as two inequalities. X is less than negative 2, or x is greater than 5. There is no way we cannot write this as an in-between statement. We can only write and statements as an in-between statement. Is everybody clear on that? So you're going to have two different number lines, or you're going to have one number line. Here's negative 2. Here's 5. Open circle going in this direction. Open circle going in this direction. So if I were talking about inviting to the party, it's anybody with pink hair or my third period. My entire third period would be invited and the pink-haired person, because I'm taking both sets. It's a union. Does that make sense? Okay, questions? No? Yes, maybe? Okay, intersection versus union. Write these notes. Okay, first of all, the intersection is an and statement. The union is an or statement. So if we get it in a word problem, was that a question or are you stretching? Okay. There's the symbol for intersection. Here's the symbol for union. So Julia, you were out, and so when I talk about intersection, that would be like, let's say I have, 1, 2, 3, let's call this set A. And we have 1, 2, 3, 4, and in set B, we have 4, 5, 6, 7. The intersection would be 4. It's what they have in common. Okay? So intersection is, I don't like to do that Coke and Pepsi thing here. I like to say this is what's in common. I pulled that pencil outward. This is what they have in common. And this is, it can look like, it can use the word and in the middle of two inequalities, or we can write the in-between statement. Right? This on a number line is going to look like one line. Right? It's going to look like one line. Most of the time. The union, it's an or statement, so it's the combination of both. We combine. This is only, intersections are only what's in common. So in that if I were saying the union of set A and B, it'd be 1, 2, 3, 4, 5, 6, 7. Combine the two sets. This is always going to be written as two inequalities. And this on the number line, everybody, is going to look like, here's 0, 2, and 8. It's most of the time going to be 2 lines. Okay? Going away from each other. Now, there's a rare exception if the 2 lines that are going away from each other, that there's some overlap. That does happen. But most of the time, it's 2 lines. Okay, can I erase this, or are we still writing?
Yeah, if it's 2 and negative 2, they would overlap.
So let's say if it's no, it would be, yeah, exactly. She's saying, so a situation like that would be x is less than 2, or x is greater than negative 2, right? It doesn't matter the order. In this situation, here's negative 2, here's 0, here's positive 2. This is a situation of overlap. So here is greater than negative 2 goes in that direction, less than 2 goes in that direction. And if it's a union, that means what numbers go into the set? All real numbers, because of that overlap situation. Okay, can I erase this?
Yeah.
That was a good question. Okay, so we're moving on. All right, so let's try and graph the compound inequality. It's an or statement. Go. You're going to pause the recording and do these 2 and then graph. Let's go. Who wants to do? Okay, Julia, the first one.
Add 3 to both sides.
Good.
And then it's 2x is less than 10.
Good.
And then you divide both sides by 2, and you get x is less than 5.
Good. And then or, let's keep going. Daisy, what's the next one?
First, you would add 7,
Mm-hmm.
and then you would have 4x is greater than or equal to 40, and then you would divide by 4 on both sides and get x is greater than or equal to 10.
Good. Okay, next one. Now we're going to graph it. What do I need to do to graph? Mike?
You need to put the point 0, 5, and 10.
0, 5, and 10. Good.
And then you draw an open circle above 5 or under 5.
Okay, so we're going to start at 5, and it's going to be 5. Which direction am I going in?
The left,
Is it an open circle or a closed?
open.
Open circle, it's going to the left. 10.
You do solid circles to the right.
Okay. All right, next, solve and graph the compound inequality. What are we going to do here? You guys want to try these 2?
Yep.
Why don't you guys pause it and you do the next 2? Okay, Maddie? How about Maddie try this one? What are we doing?
For negative 5x?
Mm-hmm.
Okay. So first you want to divide both sides by negative 5.
Good. And then?
And then you'll cross out the negative 5 from negative 5x, and then you'll end up with negative 7
Okay.
on the right side.
And the answer is?
And the answer is x is less than or equal to negative 7.
Perfect. Why did we flip our inequality?
Since you're dividing by a negative.
Good. And then the next one, we're going to subtract 1. And then we divide by negative 2 on both sides. Again, we flip the inequality. Okay, so we get x is greater than 12. It's an or statement. And so we are going to start with negative 7, go in one direction, and start with 12 and go in the other direction. It's a solid circle at negative 7 going in the left, and an open circle going to the right from the 12. Okay, how many people got that graph? Good. All right, so let's talk about ways to. You saw in the homework last night, they said, like, what is the better answer? And then they would say, like, the entire set of A. Well, we can kind of do that with the inequality in set builder notation. So let's just look at, like, what this would be. an and statement is an intersection, right? It's what overlaps. So if the first inequality is an open circle and it goes like this, right, from 5, and the second inequality, which inequality of the two, if I were trying to put this, x is such that x is, which would describe the overlap? Which inequality? Elise.
X is, oh, it's an intersection, so x is less than 3?
Yep. Do you understand that? How if we're doing this in set builder notation, Fiona, stay with me. I'm using this inequality because that is the one that really shows the overlap. Do you understand that? Because that's the one that describes both. It overlaps both. Okay. Whereas the next one it's a union, right? That means it's the combination. Whoops, I'm going to erase it. So it's the combination. Okay, so as I'm graphing it, I'm doing x is less than 5 and x is less than 3. Okay, which inequality best describes it?
X is less than 3.
This is union.
X is less than 5.
Whereas it's not intersection. Intersection's for the overlap. Union is for everything. So x is less than 5 is the better description. Does that make sense? X is such that x is less than 5. This is where you're probably getting confused, right? Do you understand, Fiona? Okay. Questions? Okay. All you do is basically draw them. When I see my number line and I see the word and, is that a conjunction or disjunction? Conjunction. It's it's a intersection. So I have to look for where is the intersection. Right? So I'm gonna, oops, I didn't mean to do that. It keeps going. Okay, so I'm doing the intersection, and that really is x is less than 5 and x is greater than 3. Are you guys seeing that? Mm-hmm. So you would really need both of them. So if I were doing set builder, what am I going to write? X is such that.
X is 3 is, 3 is less than, x is less than 5.
Yep, that would go in there to describe the situation, the best situation for. Because when we drew both of them, they're both going in the same direction. This one's going in that direction and the other one's going in that direction. So it really kind of depends on the situation. She's saying, why couldn't we do an in-between for the one up above? There isn't a lower boundary for the other one. It's an exception, really. Okay, so now let's graph the next one. Right? And we're going to do, okay, look at this. This is an or statement. That means a combination. We're going to combine everything. So x is less than 5 starts here. Are you with me? Mm-hmm. And it goes all the way. It's an or statement. It's 2 lines. But this one, the other one says x is greater than 3. Exactly what Julia was talking about. So all of these people are invited to the party, and all these numbers are invited to the party. So who's invited to the party? And so in our set builder notation, we would say x is such that x is any real number. Do you understand that exception? That was the exception that you were talking about before. The overlap. We usually don't have an overlap with or statements, but in this case we do. So let's just say 10%. Let's put a number on it. You'll have that exception. All right. Let's try some more. It takes so long to come up. So now I'm going to graph them. I need a combination. I need the overlap. Only the overlap. So x is greater than 5 and x is less than 3. What is in my set builder? What am I going to say? X is such that
X is such that x is less than 3.
it's an and statement. Where is the overlap?
There is no overlap.
So we'd say x is an empty set. I think you would just write empty set. I don't even think you'd write all that stuff. You would just put the braces and leave it empty.
Okay.
Okay, so I'm going to try the next one. And so we are starting at x is greater than 5. It's an open circle. It's an or statement. It's allowed to be two statements, right? It's an or, and x is less than 3. It's going here. We're just going to put them both in there. If I'm doing set builder, x is such that x is less than 3 or x is greater than 5. Close it up. Describing the situation. Yes, you're understanding. No, you're not. Okay. Come on. This number line takes last two. Okay, I'm going to draw it again. It's an and. That means the overlap. So x is greater than 5. And x is greater than 3. Which one best describes the overlap?
Greater than 5.
So x is such that x is greater than 5. Close it up. Okay? I guess it always looks better with their writing. Okay, yes. Is there a question, Jamie?
No, I was just.
Okay, so next one I'm going to do x is greater than 5, right? And x is greater than 3. So which one best describes the combination? Because it's an or statement.
X is greater than 5.
Greater than 5 shows the combination.
No.
X is such that x is greater than 3. And when I went to graph it, notice they only put the one that shows both of them. Does that make sense? Okay, questions? All right, that's it for the day. We are out.